Okay, hi folks. I am just going to do homework problem number 2 for you here. It's similar to the notes number 5, but I'm not sure we got to that in one of the sections. So let's just look at homework problem number 2 from related rates 1. So it's a ladder problem. And there's a 13-foot ladder. It's leaning against a vertical wall. And the bottom of the ladder slides away at a rate of 2 feet per second away from the wall, right? So this is the bottom. It's sliding away at 2 feet per second, and we're asked to find how fast is the top sliding when the bottom is 5 feet from the base of the wall. So if I were to draw a picture for this, I would draw a triangle with my ladder 13 feet, right? This slanted guy is the ladder, and it's 13 feet. It's not changing. So anything that's not changing, you can put the number into your picture, right? So 13 is not changing. It's the length of the ladder. X, which is this distance of the bottom of the ladder from the wall, that's changing because the ladder is sliding down the wall. Y, which is this distance, I'm going to call that Y, that is also changing. You have to give these things variable names. I'm calling the bottom of the ladder from the wall X, the top of the ladder from the ground Y. So this is my picture. The question is telling us that the bottom is sliding away from the wall at 2 feet per second. That means X is increasing, and the rate of change is 2 feet per second. dx dt is 2 feet per second. We are looking, that's our given rate. Our find rate is dy dt. How fast is the top of the ladder moving down the wall? And we're given a snapshot moment when X, the bottom of the ladder, is 5 feet from the base of the wall. This is the question mark, the find. Okay, so in this problem, we're going to use Pythagoras theorem. So we're going to say x squared plus y squared is always equal to 13 squared or 169 for this problem. That's the formula. And now we're going to differentiate implicitly, and it will become 2x dx dt plus 2y dy dt, right? Both x and y are functions of time, so they have to be differentiated implicitly, thinking of each of them as an inside function, okay? And that's going to be equal to 0 because the derivative of 169 is 0. This basically means a ladder is not changing in length, right? So that's a 0 on the right side. I am given dx dt, and that's 2 feet per second, so I can go ahead and in step 6 now put in my numbers. So 2 feet per second for dx dt. This x, right, it's going to be the snapshot x moment, so 5, plus 2y, right? Now here's the tricky part about this problem. I want to find dy dt, so this is fine to leave that as dy dt, but we need to put the y for the snapshot moment in. And the question doesn't tell us what the y is at the snapshot moment, but we can figure it out. Because if you think of the snapshot moment, x is 5, and we know that the ladder length is always 13. So if x is 5 and the ladder is always 13, then y is just the square root of 169 minus 25, and that works out to be 12. So that means that the y at the snapshot moment is 12. So now I can just solve this for dy dt, and I get dy dt is negative 20, that's this number, moved to the other side, divided by 24. So I get negative 5 over 6 feet per second, right? Everything here was in feet. The ladder was in feet, and this dx dt was in feet per second. So the final answer is going to be negative 5/6 feet per second.